Okay guys, what we're going to look at is we're going to look at covalent bonding today. From Teams, we had said that covalent bonding was the electrostatic force of attraction between the negative electrons and the positive nuclei. Okay, so we have a diagram here. Okay, so this is how covalent bonding usually looks. And we have the positive nuclei, and we have electrons in the middle. Okay, when you've got a shared pair of electrons here, so E minus is just the same as electrons. When you've got a shared pair of electrons, this means you have a covalent bond. So, covalent bond, if it was hydrogen, for example, okay, so let's look at a few examples. If we have hydrogen, okay, so hydrogen is diatomic, so we know it is H2. Diatomic just means that it's made up of two atoms. Di meaning two, atomic being atoms. Okay, so it's made up of two atoms. So hydrogen is H2, not just H, and you've learned this in third year. Chlorine is Cl2, not just Cl. Oxygen is O2, not just O. Okay, but we'll have a little look at them. But first, let's look at hydrogen. When we're doing this, the first thing you want to do is you always want to draw the outer electrons for each atom that's in your compound or molecule. So in this case here, it's made up of hydrogen, two hydrogens in this case, and you know from the data booklet that hydrogen has one electron. Okay, this is because the atomic number is 1. So we have one electron here. You know that because it's in the first shell, it can only have 2 in order for it to become stable, i.e. have the same electron configuration or arrangement as noble gases. So when we're drawing this, you have H here. When we're drawing this, we need to draw 2 together, okay, because it is covalent bonded. Both of them are hydrogen, and you get 1 electron from here, and you get the other electron from your second atom. Okay, and the way we draw that here is we have X and a dot and a cross. Okay, whenever you have this here, okay, that's again a shared pair of electrons. Whenever you have a shared pair of electrons, that equals a bond. So you have H and you have H, and when you're drawing that out, it looks like this here. Okay, so that's the first one. Then you have Cl2. Okay, then you have chlorine. So again, draw your outer electron diagram, just like you have here. So put Cl in the middle. Okay, now Cl will be bigger because it can hold more electrons and it's got more shells basically. Okay, more outer, one outer shell but more energy levels in total. So you have Cl, and from the data booklet you can see that the electron arrangement is 2, 8, 7. That means that there's 7 electrons in your outer shell. So the way we fill this up is you have 1, 2, 3, 4, 5, 6 and 7. You can see here that these are paired, okay, and then there's one unpaired at the left here. Now you know it's Cl2, so you need 2 chlorines, and the way we do that is we write this down again, we overlap them, and then at this point here they're sharing electrons, and that gives each of them 8. So you can see up here, there's 2 electrons, that means it's got the same electron arrangement as helium. And then here, when you draw it, okay, so we have your 2 circles. you want to put Cl in both so that you know what atoms they are. And then you can fill it in as you know it. So we'll start with the right hand side because it looks like this here. So you have 1, 2, 3, 4, 5, 6, 7. And then if you do the left hand side, it'll look the exact same. This time we use dots. 1, 2, 3, 4, 5, 6, and 7. Now this part in here is the overlapping part, and because there's 2 electrons in it, one of them coming from this chlorine atom, the other coming from this chlorine atom, it means that each chlorine atom now has 8 electrons and it's going to be stable. 1, 2, 3, 4, 5, 6, 7, and 8. If you look over here, 1, 2, 3, 4, 5, 6, again 7 and 8. So they both have 8, and that's what you're always going to look for. You're always going to look for a full outer shell of electrons. Now let's look at something like fluorine will be the exact same as chlorine. Okay, so let's look at something like oxygen. So if we have oxygen, that would be O2. Again, you draw your shell, and this time, you know, in the middle, you've got O for oxygen. Oxygen has 6 outer electrons, so we draw 1, 2, 3, and 4, and then you start pairing them up, 5, and 6. Okay, that means you've got 1 electron here, and 1 electron here that is unbonded or unpaired. You know, because it's diatomic, it's made up of 2 atoms, so then you need 2 oxygens. Okay, now we do this again by drawing your circles. You put O in the middle, and you know that you have 2 unpaired electrons. Okay, now because there is only 2 atoms in this, it's diatomic, so we draw it 1, 2, 3, 4, and then you put 5 and 6 in the middle here. Okay, because these are unpaired. And when it's diatomic, you put all your unpaired electrons in this overlapping part here. Do the exact same. 1, 2, 3, 4, and then you've got 5 and 6. Okay, now we know oxygen is in group 6, so we know the valency of oxygen. The valency just tells us the number of bonds that we're able to form, and you know because oxygen is in group 6, you're able to form 2 bonds. Okay, now this part up here, dot and X represents 1 bond, dot and X represents another bond. So every time you see dot X, that's a covalent bond. Okay, so if you have 2, you know when you're drawing it, you have O and O for your 2 oxygens. You know you've got 1 bond, okay, but you also have that second bond underneath, which makes it look a little bit like that. Okay, and then this is a double bond. So because you've got 2 shared pair of electrons, you have 2 bonds. Okay, so every time you see dot and cross, and it's in the shared part, that's 1 bond. If you see it twice, 2 bonds. If you see it 3 times, that's 3 bonds. Okay, so for example, if you want to see a triple bond, you would have N2, nitrogen. Now, nitrogen has 5 outer electrons, 1, 2, 3, 4, and 5. So we have 3 unpaired electrons here. And I've said that if you have unpaired electrons in a diatomic molecule, then they always go in the overlapping section. So when we draw this out, you have N and N, your 2 N's because it's diatomic. Okay, so if we're going to draw the structure, then we have N and N, and we'll populate this as we go. You have your paired electrons here, and we'll do 1, 2, 3. So that should get 1, 2, 3, 4, 5, just the same as 1, 2, 3, 4, 5. Do the exact same for this side here. So you've got your paired electrons here, and then you've got 1, 2, 3, 4, and 5. Okay, so now we've got 3 dots and crosses, dot cross, dot cross, dot cross. You now know, just like up here, you have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So that's stable. 1, 2, 3, 4, 5, 6, 7, 8. Again, this one here is stable because it's got a full outer shell of electrons. The exact same here. You had 5 on the left. You now have 1, 2, 3, 4, 5, 6, 7, and 8. So this left nitrogen atom here has 8 electrons. And then this right nitrogen atom is 1, 2, 3, 4, 5, 6, 7, and 8. So that also has 8 electrons. Because you've got a dot and a cross, you've got 1 bond. You've got a second dot and a cross, 2 bonds, and a third dot and a cross, you've got 3 bonds. So that there means you've got a triple bond. Okay, so hopefully that helps. And I'll show you some examples of compounds as well. Okay, so things like water, ammonia, which is something like nitrogen hydride, methane, carbon tetrachloride, and so on. Okay, and I'll show you how you can work it out. You can work out how many chlorines you would need without knowing the structure due to using the valency method and your SVSDF or swap and drop rules. Okay, so hopefully that's helped. If not, leave a little comment on Teams.